Okay, this is 6.5 homework help. The first problem gives us a tangent function. It just asks us for the period and the phase shift. So we learned that the tangent function has a period of pi over b. So just like sine and cosine had 2 pi over b, the tangent is pi over b. And we can then know that b is 6 right here. So we're going to do pi over 6 for the period. Now, the phase shift, I actually have to rewrite this. So what I'm going to do is factor out a 6 from the front of this. I'm going to write this as the tangent of 6 times x plus, this would be 2 over 6 right here. So that if I distributed the 6, I'd get back to the 2. And I still have the negative 21. So I rewrote this by factoring out a 6 from both of these two terms. Now, that tells me that my phase shift is right here. It's 2 over 6, which is really 1/3. I could simplify it to 1/3. And I should make this negative because technically if you're adding to x, you're moving back to the left. So the phase shift would be negative 1/3. Okay, the next problem then is this one. It's 2 secant of this. Now, secant is 1 over cosine, so it actually ends up having the same exact period as the cosine does. So the period of a cosine and secant is 2 pi over b, which in this case will be 2 pi over, and b is 7 pi over 2. It's supposed to be a 7. So I can move this to the top by multiplying by 2 over 7 pi, and the pi's cancel, and I end up with 4 over 7. Okay, the next problem is just like our function transformations. We're going to take the tangent and we're going to vertically stretch it by 7. So that's when we multiply 7 out front, or on a formula sheet we said divide y by 7, which is the same thing as multiplying both sides by 7 and getting this. And then we're going to shift it 5 units to the right, so that'd be x plus 5, I'm sorry, x minus 5. And then we're also going to translate it 10 units upwards. That's when we subtract 10 outside. Or add 10, I'm sorry. Okay, the next problem wants us to determine if this is true or false. Secant and tangent are undefined for the same values. What I'm going to do is rewrite secant as 1 over cosine, and I'm going to rewrite tangent as sine over cosine. So what you find is that they both have cosine on the bottom, so they're both undefined whenever the cosine is equal to 0. So therefore, I would enter true for that. Now the next problem wants us to know about the domain for tangent. The domain of the tangent is not real numbers. That's false. And the reason why is because here's the tangent right here, and it's undefined for whenever cosine is 0. Okay, tangent and cotangent are odd functions. Now we're not going to spend a lot of time talking about even and odd functions, but they are technically odd, which means they're rotationally symmetric about the origin. And then the range is all real numbers. That's true as well. And we can look at the graph of tangent. It looks like this. And you can see that it does have all y values present. Okay, the next problem gives us a graph of the tangent here, and it wants us to write an equation for this, a function for this. So we know that the period of the tangent is typically pi. Actually, it's pi over b. So we want to find out what b is by looking at what the period of this function actually is. Now you can see if we go from 0 to 1 here, the period is actually 1. So what we find is the period of the tangent function here, that I'm given here is 1. So we can do 1 equals pi over b, multiply both sides by b, and we get b equals pi. So this is a regular tangent function where the b is pi. So that'd be, when you on the formula sheet, I have a tangent of bx plus c plus d. And so we know what b is. It doesn't look like it's shifted over at all because the tangent does start off at 0. And if you want to know why, the tangent is really sine over cosine. So it starts off at 0 because when you plug in 0, the sine is 0 right here. And then normally it doesn't reach 0 again until pi when sine is 0 again. The top is 0. But this one, like I said, repeats quicker. So every time you get to 1, because our b has changed, this thing gets back to 0. So the amplitude, I'm not sure if this has changed at all. So I'm just going to try to enter this in and see if it works the way that it is. And like I said, b now I know is pi, so I can enter that in as pi x. It's not shifted over left or right like we talked about. So, and it's not shifted up or down. So my answer is just the tangent of pi x, which is right here. Okay, the next problem is kind of weird. I didn't know what section to put this in, but it's a good problem. We are going to have to do these questions where we have to solve trig equations, where you have sine of x equals 1/2. So the question is, where does the sine of x equal 1/2? And now keep in mind 1/2's right here. So we're looking at where the y value equals that. Well, we know that first answer is at 30 degrees or pi over 6. But it also equals 1/2 again over here at 180 minus 30 or 150 degrees, which is 5 pi over 6. So we want just those two answers because we're just looking for the angles between 0 and 2 pi. Now obviously I could keep rotating around, so the sine equals 1/2 here at this angle, then once again at this angle, and then once again at this angle, and then once again at this angle. There's an infinite number of solutions if I'm able to keep rotating around the circle, but we just want the ones between 0 and 2 pi, so we're just looking for these two separated by a comma. Okay, the next problem wants us to solve this equation, tangent equals 1 over tangent, and it wants the answers between 0 and 2 pi for our angle in radians. So I'm going to multiply both sides by tangent, and if I do that I get tangent squared of t equals 1. I'm going to square root both sides, and I get tangent of t equals plus or minus the square root of 1, which is plus or minus 1. So I'm looking for where the tangent of t equals positive and negative 1. That's really where sine and cosine are equal, so that I can get 1, or when I get sine of t over cosine of t equals negative 1. But if they're both equal, where, like for example, if it's square root of 2 over 2 and square root of 2 over 2, they're equal, and I would just get the 1. Or, for example, if one of these is negative, then I'd get the negative 1. So basically I'm looking for that in the unit circle. And you'll notice on the unit circle that happens here at 45 degrees where they're both square root of 2 over 2. And it also happens back here where one's negative and one's positive. That way you'll get the negative 1. And it happens here, and it happens here. So those 4 spots are my answers, and those angles are on the unit circle. We have pi over 4, we have 3 pi over 4, we have 5 pi over 4, and we also have the last one, which is 7 pi over 4. Okay, the next problem wants us to solve this equation. Now, I'm going to first factor this because I noticed that if I call like w equal the sine of t or some other variable, you can use x if you want, what you get is 2w squared minus w minus 1, and I can factor this into 2w plus 1 and w minus 1. So basically that factors into 2 times the sine of t, if I plug sine back in, and then sine of t minus 1 equals 0. So I'm solving this equation. So what I want to do is solve this equation and the other one. So to solve the first one, I set it equal to 0, and I subtract 1 from both sides. So I get 2 sine of t equals negative 1. Divide both sides by 2. So what I'm looking for is where the sine of t equals negative 1/2. That's down here. So it looks like there's 2 solutions to that in between 0 and 2 pi. One is here at 30 degrees past 180, which is 7 pi over 6. So that should be a solution. As well as over here, the sine is negative 1/2, which happens at 330 degrees or 11 pi over 6. And then I also have to get the other two. Now actually it doesn't want the pi here, so let me take the pi out because it's got the pi on the end here. So I just need to find the other solution that comes from this one. So that happens sine of t where it equals 1. If you set it equal to 0 and add 1 to both sides, we know where the sine is 1. That's up here at 90 degrees. So that'd be pi over 2 or 1 over 2 since pi is already there. There's my 3 fractions. Okay, then the last problem, final solutions to this equation. I have the cosine of x times the sine of x minus 2 cosine of x equals 0. I'm going to factor out a cosine of x, leave me with sine of x minus 2 equals 0. So what I'm looking for is the solution to both of these. Now I know when the cosine is equal to 0, that happens here at pi over 2, as well as down here the cosine 0, and that keeps repeating, every time you go around. Now there's no solutions from this part because if you set that equal to 0, the sine of x never equals 2. We know it only goes between negative 1 and 1, so there's no solutions to that part. They only come from here, where we have these 2 solutions right here in blue that work, but they keep repeating because if you go around to this, that's a solution where you'd get a 0 because the cosine would be 0. Back around to here, you'd get another 0, and if you keep going around, you'd get these zeros every time. So they want us to represent all the solutions to this, and that's where this comes in. So my solution is at pi over 2, 90 degrees, plus any increment of pi. So I usually use n times pi, but they're using k right here, so I'm going to use k instead of n. But what this means, these represent all the solutions, because it's saying that this is a solution right here, but anytime you add pi and get to this other point, that's also a solution. So any multiple of pi after pi over 2 is a solution, which is exactly what they want. So they want it to represent like this, where b in this case is 1, because a is pi over 2, b is 1 k pi.